Hi everyone, my name is Parag Paul and welcome back in my new video. In the today video, we are going to do a calculation of steel structure numerical to determine the bolt value of 20 diameter of the bolt, right? Connecting the 10 plate. So for a single shear and for a double shear, we are going to perform this calculation. So we do have a bolt used here as a 4.6 grade and plate of 410 grade. So this is what I have highlighted here, right? So this is very important video for all of you, because if you are solving this numerical in your examination, so you will not face any problem, okay? But if you not understand this properly, you will definitely face the problem, right? So let's understand it properly. So first of all, what are the given value we do have? Just understand that one. Whenever you are solving the numerical, refer what type of the grade is provided to you. So we have so that numerical is provided us a 4.6 grade, right? This is the information we do have. So first of all, for 4.6 grade, okay, for 4.6 grade, you need to do the bolt calculation, okay? So 4.6 grade of bolts, you need to calculate FUB, okay, and FYB. So these two value you need to calculate. So understand 4.6. So whatever the first number over there, you need to write here. Whatever the second number digit, okay, you need to write in the same digital pattern. Understand? Now after that, the first one, okay, you need to multiply it by 100. And the second one, you need to multiply with the FUB, the value which is here, this one. Understand? So this is one of the easiest ways to understand the steel structure. Okay, so whatever the FUB will be calculated over here, it will be 400 Newton per mm square, right? So now you have calculate FUB. So now you need to make this FUB put over here. So it will be like this, 0.6 into 400, right? So this will give 240 Newton per mm square. I hope you understand this one, correct? So this is the step number 1 to calculate the grade values FUB and FYB. Once you do this calculation, the second step you need to perform, which is you need to go for the shear strength, the strength of the bolt in the single shear and the double shear. Because see, they are asking us to calculate the bolt value. So bolt value we need to calculate in the single shear and the double shear, correct? So first of all, we need to calculate the strength of the bolt, okay? So to calculate the strength of the bolt, okay, so strength of the bolt in single shear, okay? So in the single shear, the formula is VDSB is equals to, right, VNSB divided by gamma MB. This is the formula. Now in my lecture number 1 and lecture number 2, I have explained this formula. This is my lecture number 3, okay? This is my lecture number 3 where I am explaining this numerical. So VNSB, to define this formula, the more elaboration of this formula is FUB, right, divided by under root of 3. Don't worry about all this formula. I'm going to give you very simple explanation from where you can get this formula during your examinations, right? Everything is available in the IS code. So no worries at all. I'll make one video sooner to make you understand from where you can get all these formulas, right? Now just write down this one more line. Then the another formula aligned with this one is NN, right, into ANB plus NS into ASB divided by gamma MB as it is. So here the partial safety factor, gamma MB is a partial safety factor, and its value is 1.25, okay, correct? Now let's put all the value together in this formula. So FUB you have over here, which is 400 Newton into mm square. So write 400 divided by under root of 3. Right. Now you will ask me, sir, how to provide this formula. Now you need to provide now NS and ASB. Okay. So NS into ASB, the value which you are supposed to calculate. Right. It is very important because NS is nothing but the number of shear planes without thread intercepting the shear plane. So now we are not calculating the NS over here. We only need require the number of shear plane with thread intercepting the shear plane. It means NN we are gonna consider, right? So in this condition, what we should do is we only do have A and B. We don't have the ASB over here. So for that we need to calculate the area of bolt. Okay. So area of bolt, this is A and B we need to calculate. So the A and B is equals to, first of all, let's calculate that one. So area of bolt, which is A and B, okay, is equals to, how we can calculate that one? So that formula is 0.78 into gross area. So 0.78 will keep as it is, and gross area will be pi by 4 into d square, and d is what? 20 mm diameter. It is provided to us that we are going to use the how much? The 20 mm diameter. Okay. So it is already provided that we are going to use a bolt. That's why I'm considering NS value as a 0. Okay. So we do already have the gross area bolt value over here. Understand? So the calculated value already provided. Take area bolt as a 245, already provided in your question, but we calculated separately. Okay, to confirm. So this is become 245 mm square. Now you will ask me, sir, why you have calculated? I just explained you how to calculate this one. If this value is not provided, if the area of bolt is not provided in the question, then you supposed to calculate this one. So just expand this one. Now number of bolt, that what we are going to consider is, obviously we are going to provide the 1 multiply by area is going to 245, and rest is not, we are going to consider plate, so it is 0, gamma MB is 1.25. So when we solve this one, we will get the VDSB as a 45.26 kilo Newton, right? So this is a very simple value that we got. Now similarly we need to go for the double strength. So the third one, the third option that we need to perform, okay, for a double shear strength. Okay. So for the double shear strength, what we supposed to do? It is very simple, guys, which is you need to multiply the VDSB by 2, right? So 2 into 45.26, so it becomes 90.52 kilonewton. Understand? So let's calculate the nominal bearing strength of the bolt, right? The fourth one. So nominal bearing strength of bolt. So the nominal bearing strength of the bolt is given by VDPB, okay, which is given by formula VNPB, okay, divided by gamma MB. So VNPB formula is 2.5 into KB into D into TB into FUB. Now you might be surprising that, sir, how we can understand these formulas. So don't worry, every single formula is given in the your steel table, in your IS code, right? So now we are considering the bolt value, because for this one we need to consider the bolt value. So first of all, KB you need to calculate, okay? So we are assuming few things over here as such that the E value, you can see over here, the KB we need to calculate, okay? So to calculate the KB is having some consideration, Okay, so remember KB will be smaller of, always in bracket, this value you need to calculate. This should be E upon 3 into DO. Okay, P upon 3 into DO minus 0.25. This is another one. Third one is FUB upon FU, and the fourth one is unity. So among all these four figure, whatsoever is a value, the KB should be considered that minimum value. Okay, so what we have gonna do over here is, now we do have one table. Okay, but that table I have not explained you. That is a diameter of bolt. Okay, so here diameter of bolt we need to understand. Now just understand, I'll just put you that table sooner in the next video. If you have the nominal bolt dia in mm is equals to 20 mm, which we have, correct? You understand this one, that we do have 20 mm dia. So diameter of hole in mm, that we need to consider. Okay, so diameter of hole in mm, that will be 20 plus 2. For me it is 22 mm, so that is one value. Okay, and this value, okay, this value here I am considering it as a DO. So this is my DO, right? Now I am considering the rolled edge E and pitch distance. So E is the edge distance and P is a pitch distance. Okay, so in this exam, in this numerical, I am considering E equals to 33 mm. I'll explain you after some time period, okay, how to calculate this one, and P equals to 50 mm. This is my first lecture on numerical, so I'm taking it quick faster, right? So now let's calculate all these values very quickly. Okay, so let's get started. So I'm just putting the question, the table next to it. Okay, so E value we do have 33 divided by 3 into DO value is 22. So this is become 0.5. Okay, now P value is how much? 50 divided by 3 into DO value is how much? 22 minus 0.25. So this will be calculated as a 0.5. Okay, now FUB upon FU. So FUB upon FU, we have FUB value is 100 and FU is 100. So it is 1, and already unity is kept it as it is. So minimum value is how much? 0.5 and 0.5. So KB is the smaller value of all four of these, right? So KB value here, which is we are gonna put, is become 0.5. Okay, understand? Now let's put all the value in this equation, which is already available here. So VDPB is equals to, okay, just put a very single value one by one, right? So 2.5, okay, 2.5 into KB value we consider 0.5, okay, so make it as a 0.5 multiply by D into TP into FUB, right? So D value we already know 20, right? TP is a the TP value is nothing but, I'll explain you, okay, is the thickness of the connected plates, right? The thickness of the connected plates is already provided over here. I'll explain you where it is. This one 10 mm. Okay, so let's put TP equals to 10 mm multiply by FUB. FUB we already have, which is 410, right? Just a minute. 410 divided by the partial safety factor 1.25. So we got 82,000, okay, Newton. So let's consider into kilonewton, 82 kilonewton, right? Now, so for a bolt, now here we need to calculate our answer. Okay, so bolt value, okay, bolt value for single shear, okay, is equals to smaller of single shear VDSB, Okay, remember, smaller of single share, right, strength, which is VDSB, and bearing strength, bearing strength, VDPB. Okay, VDPB. So among both of these, whatsoever value is smaller, that is your bolt value for the single. So VDPB is here 82, right? And VDSB we calculate for single is how much? It was 45.26. So 45.26 is the smaller one. So we are comparing the VDSB and VDPB. So VDSB is a 45 and VDPB is 82. So which is smaller? 45.26. So this should be 45.26, okay, kilo Newton. So this is your first answer. Second answer, bolt value for double share. So definitely bolt value for double share is, this is 82 VDPB, and the VDSB for the double share was 90. So it's very simple. So bolt value, this is also smaller, okay, bolt value for double share is the smaller value of the VDSB and VDPB. So that is 82, because here you can see it is the different one. Here we do have 90, okay, so 90.52, sorry, my bad, it should be 82 kilonewton, okay, right? So this is what I am calculating, right? So I hope you like this video. Okay, if you understand this video, give me a thumbs up. If you didn't understand, give me the comment on this numerical. I'll try to explain it more quickly, right? So have a nice day, guys. Bye bye.